Hey, welcome back to the review for the College Algebra Final Exam. We're on problem number 11. Let's get started. We've got a radical equation that we need to solve for x. And the first thing that we need to make sure of is that the radical is isolated, which it is. There's only square root stuff on the right. And so to get rid of a square root, you need to square both sides. So we're going to need to square both sides. That's going to give me x minus 9 times itself. On the other side, the square and the square root cancel, leaving me just 4x plus 9. And then we got to do the FOIL method. All right, here we go. X times x, x squared. On the outside, minus 9x. On the inside, minus 9x. Last but not least, plus 81 equals 4x plus 9. Now, if you notice, we now have an x squared in the problem, which makes the equation quadratic, so we have to set it equal to 0. And so that means that we're going to bring the 4x and the 9 to the other side. So if we move those terms over and combine like terms, we're going to get x squared minus 9x and minus 9x is minus 18x, and a minus 4x is going to make minus 22x. We have 81 minus 9. Let's see, 81 minus 9 is 72. And so now we have a quadratic equation in standard form. I wonder if it'll factor. Factoring would be the fastest way to solve. If I read the signs, they're both going to be negative. X and x give me x squared. And numbers that multiply to make 72 that add and make 22. That's what we have to answer. Are there numbers that multiply to make 72 and add to make 22? Well, let's see. 8 times 9 is 72, but 8 plus 9 is 17. So, are there other numbers that multiply to make 72? Let's see here. 72 divided by 18 is 4. What about 18 times 4? Aha! Found them. 18 and 4. So 18 times 4 is 72. 18 plus 4 is 22. And now we can set each factor equal to 0. And that's going to give us x equal 18 and x equal 4. And then we need to check those to see if they work in the original problem. Okay, so going for the check. Let's check the 18 first. So 18 minus 9 equals square root of 4 times 18 plus 9. 9 equals, what is 4 times 18? Should know that. 72 plus 9 is 81. And the square root of 81 is 9, so 18 is a good answer. Let's check the 4. 4 minus 9 equals square root of 4 times 4 plus 9. 4 minus 9, that's negative 5. And I've got a bad feeling about this already. 4 times 4 is 16. 16 plus 9, 25. However, the square root of 25 is not negative 5, it's 5. And so 4 doesn't work. So the only valid solution for problem number 11 is 18. Next problem, number 12. Graph the function. Write the domain and range using interval notation. Let's see if I can shrink that down some. There we go. Give the x-intercept as an ordered pair. Identify the transformations. Blah, blah, blah. Okay. So the first thing we're going to do is identify the transformations, since that's probably the easiest thing to do. We have a -2 outside of the square root. That is a vertical shift. Minus is down, plus is up. So this is going to be a down shift 2 units. Down 2. We notice that we have a +3 under the square root. Numbers that are added or subtracted inside the function, those make a horizontal shift. Plus is left, minus is right. So this is going to be a shift left 3 units. Now that we know the transformations and we know the parent function, we can now sketch the graph. So here's what we know. We know that a square root graph normally starts at the origin and swooshes, that's a swoosh, up to the right. Okay, that's the normal parent function for square root. Okay, but our graph is going to shift down 2, left 3. So if I go down 2 and left 3, that's going to put me right here, and that's going to swoosh up to the right, because those are the only 2 transformations. That's the graph of the function, approximately. If I wanted more detail, I could do ordered pairs. Not that necessary. But they do want the x-intercept, I see, so we probably at least need to find that. So let's make us a little table. We know the x-intercept occurs when y is 0, which means we would need to replace f of x with 0 and solve this equation. And it turns out that that's going to be a little bit of work, okay? So let's set that equation equal to 0. That's going to be the square root of x plus 3 minus 2. Let's see here. Yep, equal to 0. Moving the 2 over makes it a plus 2. Square both sides. Whoops, and I notice I wrote a 4 instead of a 3. X plus 3, and then we can see that x is 1. 1 plus 3 is 4, so that's going to be our x-intercept. And can you see that I missed it over here? Missed it. So let's go back and redo that. X-intercept is 1. And we're going to swoosh kind of like that. Up to the right. X-intercept as an ordered pair. 1, 0. Now then, we can get the domain and range now that we have an accurate graph. Remember, the domain is from left to right. And so this graph is going to start at -3 and go to infinity. You should be able to see that from the picture here. It begins at -3 and goes to the right forever. The range are the values that y can be, and that is from low to high. So the lowest that this graph ever gets to go is -2, but it will continue to rise forever. And so that's going to be our range there, -2 to infinity. And let's see if I can shrink that all down so you can get a good look at that. That's number 12, and that is the end of page 4. Next page. Problem number 13. Write the equation of the function with the given characteristics. We have the shape of y equals x to the third, 6 units left, 3 units up, and reflected across the x-axis. So that means the equation is going to start off with a negative parentheses. That negative out front is because we have the x-axis reflection. If it was across the y-axis, the negative would go directly on the x. But since it's reflected across the x-axis, the negative goes out front. All right, so left is plus. So it's going to be 6 units left, which means a plus 6. And remember that a shift left or right goes inside the function. And so that'll be inside the cube. And then the up or down shift goes outside the function. Plus is up, minus is down. And so we're going to have a plus 3 outside. And that's the equation. 13 is done. Number 14. Solve the quadratic equation by completing the square. We are going to demonstrate completing the square. We are going to give the exact solutions. So the first step that you need to take when completing the square is you need to move the constant over. Now what that's going to do, that's going to create an empty space where the constant was. And then we're going to fill in with a new constant that we come up with by completing the square, okay? So completing the square says you take the coefficient of x, which is the 4, and you take half of it and then square that, okay? Half of 4 is 2. 2 squared is 4. That's our new constant. Whatever I add to one side, I have to add to the other. So there's the new problem, or this is where we're at so far in the completing the square process. Now we have a trinomial that should factor nicely because we completed the square. On the other side, negative 63 plus 4 is negative 59. Now to factor the trinomial, if we read the signs, they're both going to be plus, x and x, 2 and 2. Now since those factors are identical, since they're both x plus 2, I can condense that down to x plus 2 squared. On the other side, we've got negative 59. And then I need to take the square root of both sides to get rid of this squared. Gives me x plus 2 equals... Now, since we're square rooting a negative number, that means we're going to get an I in our answer. 59 doesn't square root nicely, so it's going to stay 59. And anytime you take the square root of both sides, you do get a plus and a minus answer. And so that's going to be plus and minus I square root of 59, and we're almost done. Last step, take the plus 2, move it over, makes it minus 2, plus or minus I square root 59. And if it's okay with everybody, I'm going to take my handy-dandy Casio FX 115 ES Plus, and I'm going to use the quadratic solver to see if I got that right. 1, 4, and 68. Uh-oh, says the answers are negative 2 plus 8i and negative 2 minus 8i. So what did I do? What mistake did I make? Do y'all see it? Yeah, I see it. Do you see the number here was 68? When I brought it over, I made it 63. Idiot. So that's going to change, and that's going to change that, and that. Man, I'm so glad I used the calculator to check my work. So that's minus 68, which makes minus 64. Square root of minus 64. That's going to be nice. Square root of 64 is 8. And since it's negative, it gives us an I. And so that gets us the correct solutions in standard form, reduced completely. And those are the exact complex solutions. All right, number 15, solve using the quadratic formula. They want exact and approximate solutions. And so since I'm going to have to sing the song, we're going to have to move the 1 over. All right, so the first step is to move the 1 over. And that's going to give us 3t squared minus 7t minus 1. And then I can see that a is 3, b is negative 7, and c is negative 1. And now we're going to sing the song. Are you ready? All together now. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Just like that. Plug it into the quadratic formula. And that's going to give us 7 plus or minus square root of, and I'm going to use my handy dandy calculator to do 49 minus 4 times 3 times negative 1. And that gives me a 61. Now those are the exact solutions. Those are the exact solutions. I now need to plug that into the calculator to get the approximate solutions. Here we go. 7 plus, excuse me, square root of 61 all over 6. And where did they want to round that to? 3 decimal places. So when I said x, this is actually t. T equals. All right, so t is approximately 2.468. Or if I do the minus, negative 0.135. And those are, excuse me, those are rounded correctly to 3 decimal places. And so if we pull that back, and so you can see the whole thing there. Bam. I don't know, maybe I should give the quadratic formula on there just in case. T is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Just in case you need it. Excuse me, I don't know what's wrong with me today. But there is the quadratic formula. And there's all the supporting work showing how to get the exact and the approximate solutions there. And that's the end of page 5. Let's go to page 6. Number 16. Answer the following questions. Does the parabola open up or down? Well, since a is less than 0, that's going to open down. Since a is less than 0, and did y'all notice that a is negative 3? So since a is less than 0, that's going to open down. Does the parabola have a minimum or a maximum? Well, if it opens down, it's going to have a maximum, okay? Look at this. If it opens down, then the vertex is going to be at the highest point, and so it'll have a maximum. Find the vertex. All right, we have a formula for finding the vertex. It's minus b over 2a f of minus b over 2a. That is the vertex formula. And so when we plug into our formula with a and b, here again we can see a is -3, b is 24. So that's going to be -24. -24 over 2 times -3. And then f of whatever that is. So what is -24 divided by 2 times -3? Well, that's a negative over a negative makes it a positive. 2 times 3 is 6. And 24 divided by 6 is 4. So that makes a 4. And so we're going to have 4, comma, f of 4 says to plug 4 into the function everywhere there's an x. So plugging a 4 in for every x plus 144. We now need to work all of that crap out. Stuff. We now need to work all of that stuff out. From here to here, all of this red stuff goes in the calculator. All right, here we go. In the calculator, we've got -3, 4 squared, plus 24 times 4, plus 144. Geez, that's big. 192. But that's the vertex. Can't help it. And then rewrite the function in vertex form, okay? In vertex form. Oh, and it says function, so that's going to be f of x equals. What does vertex form look like? Well, vertex form is a x minus h squared plus k. That is vertex form, where h and k are the vertex, h and k. A is what it was from the beginning. A was -3. And so if we do a little rub and replace here, A was -3, H is 4, and K is 192. And so that gets our function in vertex form. Piece of cake. Next, number 17. What is the axis of symmetry? Well, the axis of symmetry, the formula is actually x equal h, which we know that h is the x-coordinate of the vertex. So another way to say that is the axis of symmetry is x equals -b over 2a, since that gives us h. And so we can say, in this case, x equals -b, which is -36 over 2a, which is 2 times 9. And if we do the work there, on the calculator, of course, checking it out, 36 divided by 2 times 9, -2. And so there is our axis of symmetry. Notice that you do need the x equal. The axis of symmetry is the equation of a line, and therefore it has to be an equation. Write the range in interval notation. Well, it would help if we know if this opens up or down, okay? So since A is positive, this parabola is going to open up, and so the range is going to be something to infinity. Since it opens up, it's going to go from whatever, actually, if you want to know what that is, it's going to be k, from k to infinity. And we know how to get k if we know h, which we do now know h is -2. And so now we're going to need to plug -2 into the function to get k. All right, so that's going to be 9 times -2 squared plus 36 times -2. All of this is going to give us k. Let's see here. 9 -2 squared plus 36 times -2, -36 is k. And so if we do a little rub and replace here, that's going to be -36. -36 to infinity. That is the range. X and Y intercepts. All right, so the x-intercept is found by letting y be 0. So if we set the equation equal to 0, we're going to find the x-intercepts. 9x squared plus 36. X. And we can solve this by factoring. We can factor out the 9x. Leaves me an x plus 4. And then if I set each factor equal to 0 and solve, we're going to get x equal to 0 and x plus 4 equal to 0, x equal -4. Now it does want those as ordered pairs, okay? So maybe I boxed that prematurely. As ordered pairs, the x-intercepts are 0, 0, because remember x was 0, and the y-coordinate of an x-intercept is always 0, and the other x-intercept was -4, 0. Those are the x-intercepts. The y-intercept always occurs at the constant of the function. And did you notice that there was no constant, okay? There was no number without a variable. And so that tells us the y-intercept is going to be at the origin. Because the y-intercept is always at the constant or the value of c. And so if I shrink that down a little bit there, trying to get that into the window. There's number 17, done. Next page. Number 18. Find the zeros and notice it says and state the multiplicity of each. Now, if your function is factored, finding the zeros is easy. 1, 2, 3. We're going to set each factor equal to 0 and solve, and that should produce 3 zeros. -6x squared equal to 0, setting that factor equal to 0. Divide by -6. X squared equals 0. Taking the square root of both sides tells me that x equals 0. I'm going to write that way the freak over here. X equals 0 with a multiplicity of 2. And if you're wondering, how did you know that? The multiplicity is the power of the factor. So whatever the exponent was on that factor, that is the multiplicity. Okay, next. X minus 9. Next factor equal to 0. Moving the minus 9 over gives us x equal 9. So x equal 9, multiplicity 1, because the factor had a 1 for a power. And last but not least, we have 5x plus 4. That factor, okay, fine, I'll write it like this. Cubed equals 0. You would need to take the cube root of both sides. Okay, but that gets rid of that anyway. 5x plus 4 equal to 0. Same thing there. And then if I move the 4 over, we get 5x equal negative 4, and divide both sides by 5. Negative 4/5. So x is negative 4/5, multiplicity 3, because that was the exponent of the factor, and these are the zeros and their multiplicities. Next problem, number 19. Graph the function using a table of values. I would like to see that. Include the x-intercepts and the y-intercepts, and at least 3 additional points, okay? At least 3 additional points. All right, so let's do a table. Like so. And the first thing I'd like to do, super easy, let's let x be 0. That's going to make everybody 0, which is going to tell me the y-intercept. Bam. And notice that is also an x-intercept, okay? But it's also the y-intercept. Next, let's let x be, let's let x be 1. And so plugging in a 1 is going to give me 1 to the third minus 2 times 1 squared. And that's going to give me negative 1. So when I'm at 1, I'm at negative 1. Right there. That's a good point. Let's see. What else can we let x be? Really, we should find all the x-intercepts. Probably would be a good idea. Let's come down here to the bottom and do that. X cubed minus 2x squared equals 0. We can factor out an x squared. And then if I set each factor equal to 0 and solve, we can see x is going to be 0 and x is going to be 2. And that means there's really only 2 x-intercepts, which means if I let x be 2, y is going to be 0. Okay. So let's keep track of what's going on here. Make sure we do what they ask for. We are doing a table of values. We do have the x and y intercepts. We need 3 additional points. The 1, negative 1, that is 1 additional point. I need 2 more points, okay? So what I would like to do is maybe pick a value of x, say around 3, because that'll be a little bit past this important area, and then maybe negative 1. So maybe 3 and negative 1 would be good choices there, okay? So let's go with 3 and negative 1. And let me get rid of this work here. That's a shame that I have to erase all that. 3 and negative 1. Okay. So, 3 cubed minus 2 times 3 squared. With the calculator, 3 cubed minus 2 times 3 squared is 9. And then negative 1. Don't forget that negative numbers have to go in parentheses. And that's going to be negative 1 minus 2 times 1, which is negative 3. And let's plot the points. 3, 9 is going to be up here. And what was the other one? Negative 1, negative 3. That's going to be here. And so we can kind of get an idea of what's going on with this graph. It's doing something, it's making a little curve in here. And then this guy's coming down. And then this guy's headed up, something like that, okay? And so that gets number 19 done the way they asked for. Graph the function using a table of values, including the x and y intercepts and at least 3 additional points. 1, 2, 3. There's the 3 additional points. And then we have the x and y intercepts. And number 20, this is the last problem in this video. Use synthetic division to find the quotient and the remainder. All right, so when you're going to do synthetic division, the first thing that you want to do is take the divisor, set it equal to 0, and solve, okay? So x plus 3, set it equal to 0, and solve. X equal negative 3. Now the negative 3 goes in a box, and out to the side of that box go the coefficients of the dividend, making sure that every power of the variable is represented, okay? So starting with x to the 4th, the coefficient is 2. X to the 3rd, the coefficient is negative 1. X squared, negative 15. X, positive 3. And then notice there is no constant, but you do have to have it represented, okay? So again, that's 4, 3, 2, 1, and none. The constant does have to be represented. And then we're going to draw a little horizontal line here. And now we're going to crank out the synthetic division. All right, so the first step is to bring the 2 down. Any number below the horizontal line gets multiplied by the number in the box. Negative 3 times 2, negative 6, goes here. Numbers that are above the line get added. Negative 1 and negative 6, negative 7. And then you continue the pattern. Negative 3 times negative 7, positive 21. 21 minus 15 is 6. Negative 3 times 6, negative 18. Negative 18 plus 3, negative 15. And I'm going to check that. I don't trust myself. 3 minus 18 is, okay, negative 15. Negative 3 times negative 15 is positive 45. And 45 and 0 is 45, okay? So the reason I drew this vertical slash here is that separates the quotient from the remainder, okay? So the quotient is all of these guys. The remainder is this guy. And does it say to write it using function notation? Oh, it does. Using function notation. And so that means that we're going to have q of x equals. Now the 2, negative 7, 6, negative 15, those are the coefficients of a polynomial of 1 degree less than the dividend. So did you notice the dividend, the biggest power was 4. And so the quotient, this is going to start off 2x to the 3rd. That's always going to be 1 degree less than the dividend. And then it keeps going. Minus 7x squared plus 6x minus 15 is the quotient. And the remainder in function notation is 45. And there you go. Problem number 20 completed. So I hope that was helpful. If you have any questions or comments, feel free to put them in the comment section below, or you can text me. And thanks for watching.